Hi, today I am going to explain you about PSoC Designer tool flow. So already do you know about PSoC microcontroller? So PSoC microcontroller, this will be having 3 ports and 12 analog 16 digital modules. So do you know about these things? And now I am going to explain you about tool flow. So now tool flow, open this PSoC Designer. So in the designer, this will be having everything. Now go for start new project, and here for example I am going to write a code for LCD, then give a name LCD something name for, and new project location, browse the location. For example I am going to browse this project on desktop, then select desktop and OK, and go for next. And do you want to create it, go for yes, I want to create this one. And now select the base part. So here you have to select like view catalog. So already we know about the PSoC microcontroller. This will be having 12 analog modules and 16 digital modules. So PSoC microcontroller having different types of families. So these are all different types of families in PSoC microcontroller. So this will be having, for example I am selecting this CY8C2946624 PVXI. This will be having 12 digital modules and 12 analog modules, 16 digital modules, flash memory, RAM memory, and 24 input IO ports and everything. So based on your application you are going to select these things. So now I am selecting this one, 24 PXI. So CY means Cypress 8C 8-bit microcontroller, 29466 is the series number. Okay, now select this thing. Now here we will be having both options, generate in main file using C as well as assembler. So always go for C language. Why? Because assembly language is tough to understood. That's why I am going to select C language. Then go for finish. Okay. Now here we can see the PSoC Designer window. So in this window, this will be having user module parameters and everything. So now I am going to explain about that things. So PSoC Designer, in this designer this will be having 3 main parts are there: device editor, application editor and debugger. Okay, so now I am going to explain you about device editor. So now I am told you device editor, application editor, debugger. So this is called device editor, and this one is called application editor, and this one is called debugger. Okay, so device editor, again device editor is classified into 2 types. So one is user module parameters and another one is interconnect view. Okay, so now user module parameters. So what are the user modules? So on left side you can see like this, these are all belongs to user module parameters. So for example I am going to select ADCs. So here you can see different types of ADCs available for you. For example here we can see like 14-bit resolution ADC, 12-bit resolution ADC and ordinary ADC, everything is there. Okay, so for your application you need some amplifiers, then select amplifiers and select the amplifiers. Here we can see comparators and PGS, programmable gain amplifier, everything, and analog communications. So here you can see DTMP and digital communications. Here we can see different types of digital modules like I2C protocol and TX, RX, SD card and UART, SPI, everything is there. Okay, and MISC digital. So here we can see output ports like display purpose like LCDs, LEDs, 7 segments and everything. Okay, so like this. So here this will be having different types of PWMs like 8-bit PWM, 16-bit PWM, and timers also. This will be having 8-bit, 16-bit up to 32-bit timers available for you. So based on your application you will go through that modules. Okay, so if we need some module, for example I need now LCD, then just double click on LCD. So automatically this will be selected at this place. Okay, so simply we are going to double click on that module, otherwise right click and select the module. This type also we can select. Okay, so for example you need some ADC, then double click on this one. Okay, like that. So now first part is finished in device editor. Device editor is already I told you, device editor is classified into 2 types, user module parameters and interconnect view. Now user module selection is over. Why? Because I am going to write a code for LCD only, so we need only one LCD. That's enough for us. Okay, so now go for interconnect view. This is the second step. Just click on interconnect view. Now we can see the interconnect view. This step is very important. So now here we can see 16 digital modules and 12 analog modules there. Okay, so now here left side you can see global resources and user module parameters, everything. So in this global resources, this should be intimate like how much frequency PSoC controller needs and CPU clock and everything. So here you should this should be like 24 PSoC microcontroller worked on 24 megahertz frequency, and here you can see different types of frequency dividers like VC1, VC2, VC3, and VC3 again classified into source and divider. Okay, so like this. And user module parameters, so global resources for all modules and user module parameters for individual modules. For example, I am selecting LCD, then we have to select user module parameters. So here we need to give some port pin. Here PSoC, already you know PSoC microcontroller having 3 ports, port 0, port 1, port 2. Now I am assigning entire port 2 for LCD. Okay, so here select port 2. Okay, so now see the difference. Here we can see entire port 2 is assigned for LCD. Okay, so now after selecting the user modules, then go for place the user modules. Now LCD is externally connected with our PSoC microcontroller, so no need to place the module. Okay, so for example, I am selecting some other module, so something called okay, select some ADC. Okay, so I am selecting some ADC 14-bit resolution ADC module. Select. Okay, now go for second step, interconnect view. Now we have to place the module. After selection, we need to place the module. Simply right click on the module and place. Now see the difference. Okay, so now this should be occupying 4 digital modules and 1 analog module. Okay, now you can see the difference here. Okay, so now after placing the module, we have to set input and output ports. Okay, so this is configurable. Then we need to place the inputs and outputs. How to means, so simply select user module parameters. Here input, give some input. So for example, this is your choice. I am giving AC B00 block. Okay, and clock, so clock is VC2. Okay, so always select unsigned format. Okay, so now you can see the difference here. Okay, so this is about interconnect view. Now here we need to select the port pins. Okay, so B side you can see like different types of ports like port 002, port 27 up to. So here we have to select outputs and inputs, port pins. Okay, so now we are going to write a code for LCD now. Then no need to select this ADC module. Just for example, I am showing you. So now delete this thing. I am deleting this thing, and now I am going to write a code for LCD. Okay, now second step also finished. Then go for application editor. So application editor is nothing but, so here we can write the code. Okay, so go for application editor. Left side of window, this window is called some project window. Here we can see source file, header files, library source, everything. Now select source files. In main C we have to write a code. Okay, so this window is called main C window. Here we need to write a code. Okay, so already this will be included with header files like 8-bit microcontroller header file and application programmable interface. So here we will be having one more advantage is this will be having data sheet, internal data sheets. Okay, so now I am going to write a code for LCD now. Then okay, so here see, in this window we have to select like MISC digital. So LCD is available in MISC digital. and here select LCD and go for data sheet, this one. Okay, here you can see one data sheet. So this data sheet belongs to LCD toolbox data sheet. So here we can see like features of LED, LCD, and overview block diagram of LCD. Okay, so block diagram of LCD and description of this LCD. And LCD, this will be having 16 pins, and out of 16 pins 8 pins are belongs to data pins, remaining 3 are belongs to command pins, and remaining are belongs to VCCs and grounds. And here we can see description of this block diagram and placements, parameters, and API. This is very important. API stands for application programmable interface. So here this will be having some commands like LCD commands only. So you are going to write a code for LCD now, then we have to select these commands only. Okay, for example, for each and every module we need to start the module first of all, then select this command. First of all we need to start the module, right? So copy and paste here. Okay, LCD start. Okay, now LCD is started. Now give a position, so copy this thing, okay, give a position, so 0,3 is nothing but first column third row. So for example I am going to give a string like now we have to give string. Okay, so select LCD PRC string. So here we need to give string. Okay, so in that string I am giving for example welcome. Okay, so this is a simple code for LCD, so simply displaying welcome on the LCD. So now here predefinedly we have to give same like this. Okay, now so coding part is finished, software part is finished. Now go for debugging, third part. So here you can see like one menu, build. Okay, so select build and build F7, press on build F7. Okay, after getting 0 errors, so this window is called command window, like command window. Here we can see the errors and everything. So here I am getting 3 errors and 2 warnings. Okay, so now rectify these errors. Okay, so how to means so directly F7 also build processor. So here why? Because here I am getting only single quotation. Okay, so this is a procedure. Okay, now after writing a code, after getting 0 errors, then go for, there is a symbol, C symbol is there, and Cypress symbol is there, and go for that one and execute the code. Okay.